Hi guys, I'm so proud of you coming back and checking your DMA on a daily basis. Some of you do a wonderful job of making sure that you come back and do what you need to do. Okay, so here we go. Let's take a look at our week 28, day 3, and we're going to start off with some multiplication equations. Remember that the two numbers that you're multiplying are called factors, right? And what we're looking for is called the product. So factor, factor, product. So we are looking for 4 groups of 1, or we can also write this using our order property. Remember we had this conversation the other day. We asked, what is it called whenever you can switch the factors in multiplication? We call that the order property of multiplication. So let's think about one group of 40. If I have one group of 40 or 40 groups of 1, that would give me, right, 40. Now, let's think about using what we know about a basic fact for this next one. What if I knew what 4 times 9 is? 4 times 9. Now, some of you may not know what 4 times 9 is, and if you don't, you could add 9 plus 9 plus 9 plus 9, right? And 9 plus 9 is 18, plus another 9 is 27, plus another 9 is 36. Now, since we are, in this case, instead of multiplying by a single digit, now we're multiplying by a multiple of 10. So what that tells you is that I could use repeated addition and add groups of 40, but that might take me a little while, but guess what? If it does, then that's okay, because remember, what we're looking for is to make sure that we're being accurate with our information. Now, if you know how to count by 4s, you should also be able to count by 40s, right? So if we were to do that, 1, 2, 3, 4, 5, 6, 7, 8, and 9, well, 4 would start us off. We could say 40, 80, 120, 160, 200, because 4 times 5 is 20, 240, because 6 times 4 is 24, so 240, 280, 320, 360. Okay, that's one way to think about it. So 9 groups of 40 would be 360, or we just take these digits and move them over one more place value. Remember, it doesn't matter how many zeros you add in the ones place. All those zeros that are in that ones place there, see all those zeros that are in the ones? When you add them all together, they're still going to be 0. There shouldn't be anything in the ones place except a 0 if you're multiplying by a multiple of 10. Okay, so this is going to be 360. Now, another way to look at this is you could take this 9 and break it up as 40 times 5, because Miss Hanamiel loves 5, right? And 40 times 4. So 40 times 5 is 200, and 40 times 4 is 160. Now you add those together, and when you add those together, you're going to come up with 360, because 200 and 100 is 300, and you don't have any 1s or 10s here, so that's 60, okay? Now, let's take a look at that last equation. 60 groups of what will give me 60? Well, if you have the same number and you're multiplying it by what? 0? Well, if you had 60 groups of 0 and you add all those zeros together, it should be 0, right? So what can I multiply times times 60 to get 60? Well, you should be able to multiply by 1. So 60 groups of 1 would be like counting by 1s, right? All the way up to 60. Okay? All right, let's take a look at this next problem, and it's a line plot, which is what we've been talking about in our math lesson. Now, I'm not quite sure because I'm looking at this title and it says ladybugs in the jar. And so I'm not sure if the ladybugs in the jar are this length or it's just the jar is filled that much with ladybugs. That's a lot of ladybugs. But anyway, let's think about what we have here. So we have 1 1/4 inches, and there are 2. So maybe those are some big ladybugs, but maybe there's 2 ladybugs that are 1 1/4 inches. Giant ladybugs. I don't want to run into one of those. All right, let's take a look at the next. We have 1 1/2 inches, and there's only 1. So remember, each X stands for just 1 or represents one of those in that particular measurement. We don't have any at 1 3/4, so we're not going to put any X's above that measurement. We don't have any above the 2 inches, so we won't put any above that measurement. But we do, if you notice here, at 2 1/4, there are 4 that are shown there for 2 1/4. So that's our line plot. Our next problem is a fraction problem. We're comparing the fraction. So we look at our denominators, and remember, the denominator tells us how many parts are in the whole. So if I count 1, 2, 3, 4, 5, 6, 7, 8, there are 8 equal parts, and we're counting. Remember, the numerator tells us how many we're counting or how many are being described. So in this case, we're describing the parts that are shaded, and those are 3/8. Now let's check and see. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have the same denominators here, so that means we're comparing the numerators and the number of pieces there are. So we have 7 shaded. Since 1 is not shaded, we know that there are 7 shaded. So now we can compare 3/8 to 7/8. Well, there are fewer 8s shaded here than here. So we can compare by using a less than symbol. All right, let's take a look at our word problem now. It says, John runs 3 miles 3 times every week. So it asks you, how many miles does John run in 6 weeks? So I'm just going to go with what I can imagine going on here. I have, he runs 1 day, 2 days, 3 days. So that's the 3 times every week. So 3 days during the week. And for every time he runs 3 miles. 3 miles every week. So, or every day that he runs. So if I add those together, let's say Monday he runs 3 miles, Tuesday he runs 3 miles, and Wednesday he runs 3 miles. And the rest of the time he takes days off. So 3 plus 3 is 6, and another 3 is going to be 9, right? Now, that's just 1 week. What would I do if I wanted to do 6 weeks? Right, I would multiply this 9 by 6 because this is just 1 week. So if I take 6 weeks and I multiply 9 miles each week, right? Each week, then we know that by the 6 weeks, by the time the 6 weeks is over, he will have run. Okay, if you don't know what 6 times 9 is, do you know what 10 times, or 6 times 9, do you know what 6 times 10 is? If you know what 6 times 10 is, which is 60, now you can subtract a group of 6 away from 60, or 60, and you will get 54. So by the end of 9 by the end of 6 weeks and running 9 miles each week, he will have run 54 miles total. How many miles does John run in 6 weeks? Okay, so now what I want you to do, and I'm going to give you a equation to do with our first set of problems. I want you to give me, and I'm just going to write it up here, what can you multiply times 30? Let's complete this. What can you multiply times 30 to give you 60? So how many groups of 60 does it, how many groups of 30 does it take to make 60? What's our missing factor here? That is your problem for today in your discussion. I will be checking later on this afternoon, and I will see you guys tomorrow to do our math lesson. Have a great afternoon, guys. It's Wednesday. We're halfway through the week.